Hi guys, and welcome back to this journey towards excellent exam results. Thank you for your feedback on the paper 1 revision video. It was pleasing to know that the video was useful and that a lot of what we discussed was in the exam. Today's revision video is for the paper 2 GCSE exam on the 3rd of June 2026. I have again looked at all the past exam papers for the last 7 years and put together a summary of revision material for the most examined areas of the UK's evolving physical landscape section of paper 2. And that is of course for the Edexcel B Geography GCSE specification. I will also include some examples of exam style questions that you can use for practice. Please feel free to stop the video and create flashcards when necessary and where needed. I will also put in timestamps so that you can easily navigate to the sections in the video that you would like to spend more time on. This video only covers the key areas that I examined. If you would like the detailed videos that cover the entire specification for all 3 topics in paper 2, follow the links in the description. Paper 2 has 3 sections. Section A, the UK's evolving physical landscape. Section B, the UK's evolving human landscape. And then section C, geographical investigations. This is for the fieldwork and involves fieldwork in a physical and human environment. We will go section by section. And in this video, we will cover the UK's evolving physical landscape, which is topic 4. Okay, let's get started. So like I've just mentioned, in paper 2, section A covers the UK's evolving physical landscape. Now this particular section is further subdivided into 3 sections, and the first section is on the UK, so the entire country, and will mostly cover geology and the landscape of the UK. Then the second section is the coastal change and conflict section. Then the third section will be the river processes and pressures section. Now in topic 4, we will cover how the UK's physical landscape has been shaped by 4 main things. And the first one is geology, so the type of rocks, and then tectonics, and then the third thing, glaciation, and lastly, human activity. So when talking about geology, it's important for us to know what different types of rock there are. And the first one, obviously, is igneous rock. And also really important to know is the characteristics of these rocks and examples for each of these types of rock, because these are likely to be in the shorter questions in the examination. So when we are talking about igneous rock, obviously this is rock that has been formed by volcanic activity, and it's the most resistant type of rock, obviously formed when lava cools down, and examples here are granite and basalts. Then we have sedimentary rocks. Now these are formed when sediment builds up in layers over time, and this is likely to take place on the ocean floor or on the seabed, if you like. And then another characteristic of sedimentary rocks is that they normally have fossils that are trapped in between them. Now because of those fossils that are trapped in between, the rocks are not as resistant as the sedimentary or metamorphic rocks. And then the other thing we need to note as well is that because they are in layers, there are bedding planes. So there's likely to be some kind of air spaces in between the different layers. So those actually act as lines of weakness, and therefore cause the rock to be a lot less resistant. Now, the other thing that we need to mention as well is that the resistance of sedimentary rocks will vary in accordance to the type of sediment that formed them. So some of the sedimentary rock will be slightly more resistant than other types of sedimentary rock. And here the examples we have are clay, chalk, sandstone, limestone, and millstone grit. Then finally, we have metamorphic rocks. Now, these are the rocks, or they are the rocks that are formed under extreme heat and pressure. They are in between the sedimentary rocks and the igneous rocks in terms of their resistance. Now, the examples we have here are slate, schist, and marble. Now, what kind of questions are you likely to get in the examination that have to do with these rocks? And the first question is to identify which one of the following is the most likely rock type of this landscape. This particular question had a picture of a hill with a horse that was carved onto the landscape, and the rock was actually white in color, which tells you that that rock type is chalk. So the students were expected to identify what type of sedimentary rock that was. And then the other clue that was in the question within the question was that it was also mentioned that it is a landscape in the southeast of the UK. Now, we'll get to that later, where we talk about how the UK is divided into two main areas, one which has the more resistant rock and another section that had the less resistant rock. So when we talk about the southeast of the UK, we are actually talking about areas that are mostly lowland landscape or have lowland landscape and are mostly sedimentary or mostly have sedimentary rock. Okay, the second question, identify which one of the following is an igneous rock. So that obviously was a question that had was a multiple choice question with several rock types, and you were to identify which one is an igneous rock. The third question is to identify which one of the following is a region of the UK dominated by igneous rocks. Of course, that has to do with upland and lowland landscape, and I believe that particular question was talking about Scotland being an area that is dominated by igneous rocks. Then number 4, explain one characteristic of sedimentary rock. So if you go back to the characteristics that we looked at for sedimentary rock, you will be able to answer that question. But of course, it's an explain question, so you'll need to write down the characteristic and then explain it. The fifth question is to identify which one of the following is a resistant rock forming higher ground. Now, of course, you'll expect that to be either igneous or metamorphic rock. Then number 6, to explain one reason why sedimentary rocks are usually eroded faster than igneous rocks. So again, there you'll need to identify the reason and then explain the reason. So we did say that they have bedding planes. The sedimentary rocks have bedding planes, and those bedding planes tend to form lines of weakness that cause the rocks to be a lot less resistant and to be a lot more prone to erosion. And then number 7, to explain one reason why rocks with many joints and faults are eroded rapidly by waves. So of course, that is referring to sedimentary rock because, like we've said, they have those bedding planes, which are what are being referred to here as joints and faults. And because of those joints and faults, the water can force its way into those joints and faults, and through the process of hydraulic action, which is a type of erosion, force its way into those cracks, and because of the pressure that is caused by that push of water, then cause those rocks to break up. Now, the next thing that we need to talk about is the influence of that geology, so the types of rock, on the relief or the topography of the UK. Now, we do know that relief refers to the height of the land. Now, generally speaking, where we have igneous and metamorphic rock, those rocks being a lot more resistant will erode a lot slower to form upland areas. Then where we have sedimentary rocks, which are less resistant, they are going to erode a lot faster to form lowland landscape. Now, if we look at this map here, we can see that we have the country divided into two main sections. So the line here that is dividing them is the T's X line. So it flow, it's all the way from the River Tees to the River Exe in the south. And it divides the country into the upland areas, which are to the north and the west of the country. As you can see, the brown color here represents upland landscape. And then to the right here, so the south and the southeast of the country, we have lowland or mainly lowland landscape. So this T's X line obviously is an imaginary line and divides the country into those two major sections. And we expect, of course, that in the north and northwest of the country, we will mostly have igneous and metamorphic rocks, which have eroded slower to leave upland landscape. And then in the south and the southeast of the UK, we will have sedimentary rock, which will have eroded faster to leave lowland landscape. Okay, so what type of questions then are we likely to get based on this particular information here? So number one, identify which one of the following is a region of the UK dominated by igneous rocks. So if you're given a map like this one, obviously you'd identify this particular area here, for example, in Scotland, which would be an example of a region in the UK that is dominated by igneous rock. Then identify which one of the following countries in the UK has the highest mountains. Again, that is Scotland. Then explain one reason why precipitation is higher in the western regions of the UK. Now, that particular question has to do with the relief and relief rainfall as a result. Now, we know that in the UK, we receive the North Atlantic Drift, which is a southwesterly air mass that is coming from the southwest of the UK. So it's coming from the Gulf of Mexico, and because it has been blowing over the ocean, it's going to pick up moisture, and as it reaches the UK, the western parts of the UK, it's going to be forced to rise by that mountainous landscape. And as it rises, it's going to cool down and condense to form clouds, which will then give relief rainfall. And that is why precipitation is higher in the western regions of the UK, because there are mountains there. Then explain one difference in the climate of uplands and lowlands in the UK. Now, that is just what we've talked about. So in the climates of the upland climate will have a lot more rainfall and will also be a lot colder, because we know that we lose temperature with altitude, which then means that these areas in the western part, in the upland areas, are likely to be a lot colder. So cold and wet. Then, of course, to the south and the southeast, it's milder in terms of temperature, so it's not as cold, and the rainfall is not necessarily as high as the areas that are upland, where you're receiving that relief rainfall. Then the next question is to analyze. So this here was an 8-mark question, and there were two figures that were given. So to analyze figure 4A and 4B, now I don't have those here, but we'll just discuss it shortly, which shows data about the distribution of igneous and metamorphic rocks in the British Isles and its relief. So you have data showing the geology, and then data showing the relief. Now the question was to assess the influence of geology on the landscape of the UK. Now, of course, it's exactly what we've talked about here, where we are saying that the geology of the UK will influence the landscape, because where we have sedimentary rock, we will have lowland landscape, because that sedimentary rock is going to erode a lot faster rather, to leave lowland landscape. And then where we have metamorphic and igneous rock, that rock is going to erode slower to leave upland landscape. Now, of course, you're going to compare that to other factors that influence the landscape of the UK. And like we said at the start of the video, we talked about other influences. We talked about the influence of glaciation, which we shall look at in detail a little later on. And then we have the influence of tectonic activity as well. And then, of course, we have human activity as an influence on the landscape of the UK. So we can then debate this here, because it's an assessed question. Obviously, we can debate those four different influences, and then come to a definitive conclusion or decision or judgment as to which one of them we think has the most influence on the landscape of the UK. This is actually a really good question to answer in the examination if it was to come up. Okay. So let's discuss geology, tectonics, and glaciation further. Now, this picture here that we have is of Malham Cove, which is an upland landscape in the Yorkshire Pennines. Now, it was once a huge waterfall at over 80 meters high, which is 30 meters higher than the Niagara Falls. Now, this can be explained by three factors. Number one is its geology, so the rock type. Then number two, past tectonic processes. And then thirdly, glaciation. So if we talk about geology first, so the UK was once covered by tropical seas around 300 million years ago. Now that period is referred to as the Carboniferous period. Now it had tropical fish and coral, just like the Great Barrier Reef in Australia. And as the fish died, obviously, they fell to the ocean floor, and together with the deposited sediment, they formed horizontal layers, which eventually formed Carboniferous limestone, which is a type of sedimentary rock. The layers varied in hardness, the most resistant being Millstone grit, which forms the highest peaks here in the UK, or in the Pennines, if you like, so to be a little more specific, and protects the sands and the shales that are below. So the less resistant rocks, or layers rather, lie below that Millstone grit. Now that is what you can actually see in this particular figure here. And as you can see, the Millstone grit is right at the top. So the Millstone grit would be the one that is right at the top here. Yeah, so it's actually shown right here. And then the sands and the clays are below here. So we'll then move on to talk about the tectonic processes and glaciation in a minute. Now, what type of question would you get based on this information? So to explain why fossils are likely to be found on this landscape. So you'd be talking about the way the landscape was formed. You'd be talking about that Carboniferous period, around 300 million years ago, which was when the UK was beneath the tropical waters or tropical oceans. And at that time, the sediment was accumulating, or accumulated rather, and formed this particular kind of landscape. Now, let's move on then to see how the UK then ended up being above those tropical ocean waters. So what role did tectonic processes have in shaping the landscape of the UK? Now, since the Carboniferous period, which we said was around 300 million years ago, the rocks in the Pennines have been affected by three main tectonic processes. And one of them, obviously, is continental drift. And the plate on which the UK sits moved away from the tropics. So we know that the tropics are located closer to the equator, so at around 30 degrees north of the equator. And of course, the UK is located at around 55 degrees north of the equator right now. So its current location was determined by that continental drift. So that's one of the tectonic processes that has influenced or has impacted on the UK landscape. And then the second tectonic process is uplift. Now, the Carboniferous limestone rock below the sea was pushed upwards to form land. Now we know that tectonic processes sometimes will have rocks pushing against each other, especially when you have convergence, and a lot of times it will occur at a convergent plate boundary. Now, of course, as those rocks push towards each other, they are likely to buckle upwards, and that's what we are referring to as uplift. So obviously, if the sedimentary rock or carboniferous limestone initially formed below the sea or below the ocean, I mean on the seabed, then with that tectonic uplift, it's likely it then found its way above the ocean surface. And of course, there had been continental drift, so moving it up latitudinally, so up to 55 degrees north of the equator, and then they're pushing towards each other, causing it to rise above the seawater. And then the next process is faulting. Now, faulting here refers to some of the rocks snapping during that uplift. And that formed steep edges known as fault scarps. And an example of a fault scarp here in the UK is Gigglewick Scar, which is this area here that is shown on the landscape. Now, what kind of question would you get based on this information that we have here? So, explain one way in which tectonic processes have affected the physical landscape of the UK. So you could talk about, the uplift and the faulting, leading to fault scarps, for example, for the faulting, right? So you could explain one of these points that we have here. So we've talked about geology and tectonic processes. Now let's move on to glaciation and see how it affected the UK landscape. Now again, we have this figure here, which is a cross-section of Wharfdale, which is a valley in the Pennines. Now, as the Pennines were uplifted, drainage basins were created, with rivers like Wharfdale eroding into them and creating V-shaped valleys like the one that is seen in this picture here. So we have a picture here, and you can see that this is a V-shaped valley that has been created by vertical erosion by River Wharfdale over here, or the river right at the bottom here. So of course, this is an upland landscape, and in upland landscapes, the rivers normally erode vertically. So they are eroding downwards, they are cutting downwards, and that's why you have steep slopes on either side, or a steep slope on either side, due to that river cutting vertically. However, glaciation changed this completely around 10,000 years ago. Now, huge glaciers widened and deepened the V-shaped valleys into U-shaped valleys, as seen on the next photograph here. So you can see that the shape of the landscape has changed from a V shape to a U shape, and that's because if you have glaciation taking place, it means that you have large or huge sheets of ice that are flowing, or glaciers they are called, that are flowing across the landscape. And we know that they will occupy a lot more volume, and they are likely to have a lot more erosive power. So they are going to erode this V shape into a U shape, because a lot of the landscape will be eroded by those fast flowing sheets of ice. And of course, if we were to be asked about this here in an examination, we'll talk about that glacial period, yes, changing the V-shaped valleys here in the UK, river valleys in the UK, into U-shaped valleys. Okay, so examples of questions that we could be asked in the examination. So explain one impact of glaciation on the landscape of the UK. So this is where you say that V-shaped valleys were changed into U-shaped valleys by the ice sheets that flowed through the landscape and eroded those V-shaped valleys. And then another one here, so this one here was an 8-mark question, and this one was to analyze a figure which showed selected glaciated and unglaciated landscapes in the UK. So assess the varied impact of glaciation on the landscape of the United Kingdom. So this particular question did have information showing different impacts. So you are then to look at those different impacts of glaciation and then talk about each of them and then decide which one of them is the most influential in creating the landscapes here in the UK. So we've talked about geology and tectonic processes. Now let's move on to glaciation and see how it affected the UK landscape. Now again, we have this figure here, which is a cross-section of Wharfdale, which is a valley in the Pennines. Now, as the Pennines were uplifted, drainage basins were created, with rivers like Wharfdale eroding into them and creating V-shaped valleys like the one that is seen in this picture here. So we have a picture here and you can see that this is a V-shaped valley that has been created by vertical erosion by River Wharfdale over here, or the river right at the bottom here. So of course, this is an upland landscape, and in upland landscapes, the rivers normally erode vertically. So they are eroding downwards, they are cutting downwards, and that's why you have steep slopes on either side, or a steep slope on either side, due to that river cutting vertically. However, glaciation changed this completely around 10,000 years ago. Now, huge glaciers widened and deepened the V-shaped valleys into U-shaped valleys as seen on the next photograph here. So you can see that the shape of the landscape has changed from a V-shape to a U shape, and that's because if you have glaciation taking place, it means that you have large or huge sheets of ice that are flowing, or glaciers they are called, that are flowing across the landscape, and we know that they will occupy a lot more volume and they are likely to have a lot more erosive power. So they are going to erode this V shape into a U shape because a lot of the landscape will be eroded by those fast flowing sheets of ice. And of course, if we were to be asked about this here in an examination, we'll talk about that glacial period yes, changing the V-shaped valleys here in the UK, river valleys in the UK, into U-shaped valleys. Okay, so examples of questions that we could be asked in the examination. So explain one impact of glaciation on the landscape of the UK. So this is where you say that V-shaped valleys were changed into U-shaped valleys by the ice sheets that flowed through the landscape and eroded those V-shaped valleys. And then another one here, so this one here was an 8-mark question, and this one was to analyze a figure which showed selected glaciated and unglaciated landscapes in the UK. So assess the varied impact of glaciation on the landscape of the United Kingdom. So this particular question did have information showing different impacts. So you are then to look at those different impacts of glaciation and then talk about each of them and then decide which one of them is the most influential in creating the landscapes here in the UK. The next thing we need to know, as far as our specification is concerned, is the 3 types of weathering. Now we know that weathering refers to the breakdown of rock. There are 3 types of weathering. The first one being physical weathering, which is also sometimes referred to as freeze-thaw weathering. And freeze-thaw weathering is where you have water entering into cracks in the rock during the day. And then at night, that water will freeze. Now, the water will ordinarily, the ice rather, when it freezes, the water freezes into ice, the ice will occupy 10% more volume than the water will do, which then means that that ice is going to push the crack outwards, or the crack in the rock outwards, and eventually, with this process repeating itself over time, that rock is going to break up. So that is freeze-thaw weathering, and is likely to take place mostly in the upland landscapes here in the UK, because that is where we have variation or huge variation in temperature. So daytime temperatures obviously will be above freezing, and then nighttime temperatures will drop below freezing such that that water will freeze. And then we have biological weathering. Now, biological here referring to the fact that it's caused by plants or animals. So biology is the study obviously of plants and animals, and we are talking about either plants or animals causing weathering to take place. When it comes to plants, those plant roots are going to go into cracks in the rock, and as the plant grows bigger, so do the roots. And as that happens, obviously, the roots are going to push those cracks wide open, and eventually that rock is going to break up into smaller pieces. Now, as far as animals are concerned, we have burrowing animals such as rabbits, and as they burrow into the soil, they are likely to break up rocks. So that is biological weathering. Then lastly, we have chemical weathering, and chemical weathering is where there are weak acids in the rainwater. Now, those weak acids are going to break down the composition of some types of rock and cause them to dissolve into the water. Now, examples of rocks that will dissolve in the water are limestone and chalk. So it's the weaker rocks such that are sedimentary in nature, so to speak. So they are not necessarily very well held together and are likely to be affected a lot more by chemical weathering. Now, what type of questions are we likely to get based on this? So these ones we'll go through quite quickly. So identify which one of the following is the best definition of weathering. So we did say that the definition of weathering is the breakup of rock. And then to identify which one of the following is a weathering process, you would have, that was from a multiple choice question that had several choices. And then explain one way in which rock is weathered. So here you would state one type of weathering and then explain how it takes place. But again, this could be a 4-mark question. So you would need then to explain the whole process in a lot more detail. So the second subsection in section A of paper 2 is going to be coastal change and conflict, as you can see here. And the first thing we need to discuss when talking about coastal change and conflict is the type of coastlines that we have. So we have two types of coastline, one being discordant coastlines, and then we also have concordant coastlines. Now, these here are determined, the type of coastline will be determined by the layout of the geology in that particular coastline. Now, if we look at the first one here, when we are talking about discordant coastlines, these are coastlines that are perpendicular or at right angles to the coast. Now, you can see here on this Swanage coastline here in Dorset that this geology here is perpendicular to this part of the coastline here. So it's at right angles. You can see it's perpendicular. If we are looking at it from this direction here, so from this direction, from the east, if we look at it from the east here, if we are standing right there and we are looking at it here, we can see that it's perpendicular or at right angles to the coastline. Now, of course, when we have different bands of rock, like we do here, you are likely to have some of those rocks eroding faster than others. And that will lead to the formation of bays and headlands at a discordant coastline. And you can see that that is what has happened here in Swanage, along the Swanage coastline, because you have a headland here, for example, which is Ballard Point. You can see that this area here is sticking out to the sea a lot more than the bay here, Swanage Bay. And then we also have Studland Bay at the top here, which is another bay that has formed due to softer rock. And then we have another headland here, which is Dalston Head. So this is a more resistant rock. So we can say that at discordant coastlines, the rock strata is perpendicular to the coast, and it leads to the formation of bays and headlands. Then we have concordant coastlines as well. Now, concordant coastlines are where the geology runs parallel to the coast. Now, if you look here, you can see that the sea now is right down here, and the strata is going across. So it's parallel to the coastline. Now, of course, again, we are likely to have different bands of rock. Now, in this particular coastline here, we have a more resistant rock right next to the sea here, right? So adjacent to the coastline. Now, then we have beyond that less resistant rock strata, and as a result, of course, we know that this more resistant rock here that is right next to the coastline is, I mean to the sea, is still going to be eroded, only at a slower rate of erosion. But then when the water eventually gets to the softer rock or to the softer strata, it's going to erode that a lot faster and is going to erode it inwards as well. So you can see that this entry point for the water here is a lot narrower than what has been eroded behind this main rock here. And what is behind obviously is less resistant rock compared to the one that is right next to the sea, and therefore it has eroded a lot faster and a lot more outward. Now that eventually forms what is referred to as a cove, and that is what we can see here. Now at the back here obviously of this cove, you're likely eventually to get to some kind of resistant geology as well. Now that resistant geology right at the back of the cove is going to form cliffs. So at a concordant coastline, you're likely to have both cliffs and coves forming. Okay, so what kind of questions then are you likely to get for this particular information here? Number one, explain the difference between concordant and discordant coastlines. You may use a diagram to help your answer. Now that is 4 marks. So obviously you would talk about the way the strata, the rock strata or layers, if you like, are laid out. For discordant, they are perpendicular to the coastline and they lead to the formation of bays and headlands. And then concordant coastlines, the rock strata or the geology is parallel to the coast, to the coast, and leads to the formation of coves and cliffs. Then the next question here is to explain how coastal erosion processes create cliffs. You may use diagrams to help your answer. So you can explain what we have just talked about here when discussing concordant coastlines and the formation of cliffs. So the next thing that we need to talk about is erosion along coastlines here in the UK. Now, erosion is the wearing away of rock by wind, water, or ice. Now, in this particular case, we are talking about erosion by waves because we are at the coast. Now, waves obviously then become extremely important when talking about erosion at the coast. And those waves are caused by the friction that results from the wind blowing over the surface of the water. Now, that friction that is caused obviously causes a buildup of water, which is what forms the waves. Now, the more the distance of open water that wind has blown over, the larger the wave is likely to be. And that distance over which the wind will have blown over is normally referred to as the fetch. And that's a very important keyword to remember because you may be asked to define what the fetch is. And the fetch is the distance that the wind has blown over open water. So open water, the surface of the water, on the ocean. Now, how does that then impact on the waves? So the longer the distance or the longer the fetch, the bigger the wave. Now, we know that we tend to have stronger winds in the winter here in the UK, which then means that the larger waves that we get here in the UK normally occur in the winter. And those types of waves are referred to as destructive waves. So they are referred to as destructive waves because they destroy the coastline. And then the ones that occur in the summer are referred to as constructive waves because they build up the beach. They do not destroy it. So let's look at the difference between those two. Now, like we've said, the destructive waves occur in the winter and are also referred to as plunging waves. Now, they are plunging because they are dropping down. If you look here at this diagram here, you can see that this wave is really high. So the wave height is high for a destructive wave, and the reason is the wind has blown over a lot, a huge area of ocean water or surface water, and then on top of that, the winds were also really strong. So they have led up to they have led to the buildup of a very high wave, and these waves also tend to have a very short wavelength or to have shorter wavelength. So the wavelength is the distance between two crests of a wave, and the crest of the wave is the top part of the wave. So the wavelength will be a lot shorter, and of course these other smaller waves behind it are going to be pushing this one even more. The leading wave, they are going to be pushing it a lot more, and because it's high, when it gets onto the coast, it's going to drop down onto the beach with a lot of force and energy, and due to that, it's going to disturb the material that is on the beach, so loosen the material and then drag it back as backwash takes place. So you'll imagine that the beach profile in this area, in this coastline here, will be fairly steep because of the plunging wave or the destructive wave, because it will have hit the sand and then drag that sand right down through that process of backwash, which then means that it will be a lot steeper here. If so the beach profile will be a lot steeper where you have destructive waves, and we did say that these destructive waves are taking place in the winter. So we could actually conclude when talking about destructive waves that they have a stronger backwash than swash, because the swash here would be a lot weaker because the wave is a lot higher, right? So it is the plunge of the wave that is going to cause a huge backwash. Okay, because the bottom part here is not necessarily dragging that much on the beach. The wave is a lot higher here, and then when it plunges down, it loosens the material and then drags it back. So the swash is a lot weaker compared to the backwash. So that's why it destroys the beach. Now, moving on to constructive waves. Now, these tend to have a stronger swash than backwash. And they happen in the summer because in the summer, obviously, we have gentler waves coming in. Now, because the water is washing up a lot more gently onto the coastline and onto the beach, that gives the water time to sink into the sand before it then starts washing back towards the sea. Now, of course, that infiltration and percolation of water into the sand is going to reduce the volume of water that is going to be flowing backwards as backwash, meaning that the swash will have been stronger than the backwash. And we know, of course, that this wave is carrying sediment or material, and that sediment it's carrying is going to be deposited as the water infiltrates the sand on the beach, and then it's going to be deposited and left on the beach, meaning that you will end up with a wider beach that has a more gentle profile. Now, we do know that the beach is the basic protection for the coastline, because if you have a wider beach, it's going to slow down the waves and reduce their impact. Now, the constructive waves are also known as spilling waves. Now, what kind of questions are you likely to get based on this information here? So to state the type of wave shown. Now, obviously, if you were to be given these two, you would know straight away that that's a destructive wave and that's a constructive wave. Identify which one of the following is the most likely cause of waves such as these. So that there was a multiple choice question with choices that you could pick from. Now, obviously, having discussed that information, you'd be able to answer that question. Explain one way in which wave height affects the rate of coastal erosion. Now, that's again a very nice question that would be easy to answer, because wave height means that it's a plunging wave, and as it plunges down or as it hits the coastline, it's going to do so with a lot of force and therefore loosen the material on the beach and drag it back, causing erosion. So if you wanted a simpler or a more straightforward explanation, you'd say that the wave height means that that wave has a lot more erosive power and therefore will cause a lot more erosion. Then explain two reasons why coastal erosion is faster in some parts of the UK than in others. Now, you could talk about the fact that some parts, obviously, of the UK are getting destructive waves, and because of those destructive waves, they are going to erode a lot faster, and especially in places where there's a lot more open water. So the fetch will be a lot stronger. If we are talking about areas that are getting destructive waves, we could be talking about areas where the prevailing wind is going to be very strong during the winter, and as a result, that is going to have a lot more erosive power and cause a lot more erosion. Now, the other thing we could discuss here that doesn't have to do with the waves is the geology of the area, because if the geology there has a lot softer or less resistant rock, then it's going to be eroded faster. And then the other thing we could talk about is the fact that some parts of the UK have management in place, so coastal defenses that have been used. Now, if a place, for example, has a seawall or groins or rock armor, which you refer to as riprap as well, then those areas are likely to erode a lot slower. So there are a lot of ways to answer this particular question. Now, the last question here asks you to explain one reason why some coastlines here in the UK are protected while others are not. Now, of course, that would be a really good question, because you then talk about the fact that some areas have destructive waves while others have constructive waves. Now, you could then justify that and say, obviously, that areas that have destructive waves need protection and therefore will be protected, while areas that have, mostly get constructive waves do not necessarily need protection. Then you could also talk about the fact that a cost-benefit analysis is likely to have been done to determine whether that area is worth protecting or not. Now, of course, if the area is valuable, so it has infrastructure, it has people's houses, it has housing, it has road infrastructure and so on, then that will justify management or protection. So that's another reason that you could talk about for this particular question. So having talked about the types of waves, it's important for us to mention the types of erosion. Now, we said earlier that weathering is the breakdown of rock. Now, when that rock breaks down, it's likely to be eroded. Now, there are 4 different types of erosion, and when talking about constructive and destructive waves, and especially the destructive waves, they are going to use some of these types of erosion to erode the landscape. And to begin with, it's important for us then to talk about what erosion is. And erosion is the wearing away of land by water, wind, or ice. Now, in this case, obviously, because we are talking about the coast, we are talking about the wearing away of the land by the waves. Okay, so what types of erosion are there then? So we have hydraulic action. So hydraulic action involves the shear force of the water or the waves forcing its way into cracks in the rock and causing compression of air. Now, that compression of air creates a lot of pressure. And then as the wave retreats, that compressed air blasts out of that space or that crack and causes the rock to disintegrate. So in so doing, it's eroding that particular landscape. So if it's a cliff, the cliff will end up being eroded and is likely to retreat or to move back. Then we have abrasion. Now, abrasion has to do with scraping. So this is where rock and sediment scrape against the cliffs and cause them to wear away. Now, I like to look at it like a sandpaper action. If we have sandpaper and we are trying to sand down wood, and we keep rubbing the sandpaper on that wood is going to wear away, and you're likely to end up with wood chippings or wood filings. Now that is actually to show that the wood is actually being filed down. So abrasion acts in the same way. Then we have attrition. Now attrition I like to look at as a boxing match, and this is where you have rocks along the coastline. As they are moved around by the waves, they keep knocking into each other, and because of that they break down into smaller pieces. So that's attrition as a type of erosion. Then we have solution, and this is similar to the solution when we talk about weathering. And solution is where weak acids in the water cause some of the types of rock to dissolve. So they break down the mineral composition of those rocks and cause them to wear away or to erode. So that is solution, and some of those rocks will then dissolve in the water. So for example, limestone and chalk will dissolve in water, so they are they end up being in a solution state. Okay, so what kind of exam questions are we likely to get based on this information? The first question here says to explain one reason why rocks with many joints and faults are eroded rapidly by waves. So here we can talk about the fact that hydraulic action is going to act on those joints and faults in the rock and compress air into those joints and faults, and as the wave retreats, the compressed air is going to blast out of that rock and cause that rock to disintegrate. So in so doing, then such a cliff is likely to be eroded a lot faster or rapidly by the waves. Then the second question here asks to explain two ways in which waves can erode the landscape. So for this particular question, all you need to do is to pick one of these types of erosion and then explain it. Okay. Now the next part of the specification, and that is important for the examination, is the erosion of a headland. And that erosion of the headland leads to the formation of caves, arches, stacks, and stumps. Now, we have just talked about erosion, so it was important for us to talk about erosion before we then talk about how a headland is eroded. Now, when we were looking at discordant coastlines, which are the coastline where the geology runs perpendicular to the coast or to the sea, we mentioned that geology leads to the formation of bays and headlands. Now, the bays normally end up being sheltered by the two headlands on either side, and because of that, they are low energy areas or environments, so the bays. So what tends to happen there is that you will have deposition due to that sheltering by the headlands on either side. Sand will be deposited, and there will be a beach forming in most cases on at a bay. But then at a headland, because the headlands are still sticking out into the coast or into the ocean or to the sea, if you like, they are likely to still be quite exposed to the waves. Now, of course, this is harder rock or more resistant rock, because we did say that the headlands erode slower because their geology is a little more resistant. However, they will still erode over time, only slowly or slower than the bays eroded. So what happens then at a headland? Now, we do have an image here of a headland. Now, what I'd like you first of all to think in your mind is that this headland here is complete, and that these landforms here have not yet been formed. Now, if that's the case, then it means that this headland will be all the way up to here, and all this will be rock. Even in between here where we have spaces, all this will be rock, and it will be a full headland that goes all the way up out to here. However, as the waves keep attacking this particular headland, what's going to happen is that there will be initially a crack, so a crack like this one that is here. So the waves will keep on attacking this crack. And we talked about two types of erosion that would be at play here. So you'd have hydraulic action, so the shear force of the water forcing its way into this particular crack here. And then as the wave retreats, the water blasts out and therefore disintegrates a rock. And over time, both hydraulic action and abrasion, so the scraping action, is going to cause that crack to continue to erode. Now, as it continues to erode, it will become a lot bigger. Obviously, the hole will become a lot bigger, and eventually it becomes a cave. So it opens up and becomes a cave. So it's what we can see over here. And then the cave becomes even larger with time and with more erosion. Then, of course, as this process of erosion continues, so hydraulic action and abrasion, that headland is likely to erode all the way through, such that it then forms an arch. So the arch here has been formed due to the headland being eroded all the way through. Now, of course, the roof of this headland here is going to be undercut, or has been undercut, obviously, because below it, we do not have anything to support it. So the pull of gravity is going to be acting on it to try and pull the rest of the material that is up here down. And then on top of that, there will also likely be weathering processes, which are also referred to as subaerial processes. So, for example, you may have chemical weathering or biological weathering taking place at the top or on the top of this particular headland. And if you have chemical weathering, for example, it's likely to weaken this roof of this particular headland. And in time, as it's weakened, then eventually, because there's also no support from the bottom, it's likely to collapse. Now, if that roof collapses, then you remain with a freestanding landform here. And the freestanding landform here is what is referred to as a stack. So this here is a stack that has been formed when the roof of the headland or of the arch, sorry, collapsed due to the pull of gravity and due to subaerial processes. That freestanding stack is still going to be exposed to erosion and is likely to be attacked by the waves at the bottom here. Now, as those waves continue to act on the bottom here of the stack through hydraulic action again and through abrasion, that stack is going to be eroded all the way down, and what you're going to end up with is a stump. So the stump is a very short version or a very small version of the stack, and sometimes it will be covered by water, especially when the tide is in. And then when the tide goes out, it's likely to be slightly exposed, but it will almost be at the water level, because that's the level that has been where the stack has been attacked by abrasion and hydraulic action, and has finally given way to form that particular stump. Now, what kind of questions then? Exam questions have been asked in the past and are likely to be asked. So explain how a stack forms. Now, that question actually should be 4 marks. You would then explain the process all the way from the crack here to the cave becoming a little bigger, and then to the arch, and then eventually to the subaerial processes compromising the roof of the arch, and then that arch collapsing to leave a stack. Then the next question here is to describe the erosion of a headland. You may use a diagram to help your answer. So again, you're describing that full process, and you may also draw your own diagram to illustrate that. Now, of course, do remember that if you're drawing a diagram, you must make sure that that diagram is well annotated and also explained, because you need both to be able to secure the top level marks, so the full 4 marks. So it's important to have annotations and also an explanation at the bottom. Then we have question 3 here. So explain how coastal erosion processes create stumps. You may use a diagram to help your answer. Again, this is similar to these other two questions here. So as you can see here, the way the questions are worded may vary, but you are obviously just talking about the erosion of a headland, and you're using a diagram to describe or to explain that process of a headland being eroded. One of the most important coastal processes that our specification requires us to know is longshore drift. Now, longshore drift, simply put, is the movement of sediment along a particular coastline in the direction of the prevailing wind. Now, we have a diagram here that is going to help us explain that. And of course, we have a sediment that is going to be moved by longshore drift along this particular coastline. Now, the first thing to note is that the wind direction here is very important. We've just talked about the prevailing wind, and obviously it's a prevailing wind direction. So the direction from which the wind is blowing and where it's blowing. So the wind here, the prevailing wind is southeasterly prevailing wind. So it's bringing in, it's blowing in from the southeast. And of course, as that happens, it will also determine the wave direction, because the waves are caused by the wind blowing over the surface of the water, and that friction causing those ripples and eventually waves to form. So, having then established that, we can see that this particular pebble is going to be moved up the coast or up the beach in a similar direction to that wind direction. Now, of course, that's the swash. So the swash will be at an angle, and then the backwash will be at a right angle. Then the swash again will be at an angle, and then right angle for the backwash, and that process will keep repeating itself. And of course, the direction of the longshore drift in this particular instance is going to be in a westerly direction, and will have been determined by the prevailing wind direction and therefore the wave direction. Now, what kind of questions are you likely to be asked about longshore drift, or have been asked in the past? So the first one, state the process that moves sediment along this coastline. So this here was a question where a picture was provided for the students, and they were to name the process, and obviously that process was longshore drift. Then identify which one of the following is the best description of wave direction. So here again, a picture was provided, and it showed waves along a particular coastline, and the students were to determine then what the wave direction was from that particular image. It was a multiple choice question. And then the last one here says to explain how hard engineering has been used to protect this coastal landscape and community. Now, this again was a picture, and it was a picture of an area, of a coastline rather, that has longshore drift taking place. And groins, which are a form of hard engineering, had been used to protect that particular coastline. So this is a 3-mark question. So what would we say then? So we would say that groins have been used to protect this particular coastline. That would give us our first mark. And then we would then continue on to say that the groins are going to they're going to stop the movement of sediment or sand along this particular coastline. So they are going to inhibit longshore drift from taking place. Now, that would be our second mark. And then we would then go on to continue. Continue on to say that this will lead to the formation of a wide sandy beach. Now, why is that important? We could then continue on to say that the beach is a basic protection for the coastline, or the beach will act as a defense because it will absorb the power of the waves and therefore protect this coastal landscape and community. So by doing that, then we'll have achieved those top level marks. Obviously, the top level here being 3 marks. Okay. The next really important part of the specification is the depositional landforms that are created by longshore drift. And in this case, we are referring to the formation of spits, hooks, and salt marshes. Now, what's happening then along this particular coastline? So This here is a slightly different prevailing wind because it's blowing in from a southwesterly direction, but it's still moving that sand along this particular coastline. Now, as that sand is moved along the coastline, you may end up having the coastline changing. Now, of course, or coming to an end, because as you can see here, the coastline here comes to an end and then it changes and moves on to this other side. Now, that would lead to a change in the wind direction as well, as in terms of the direction from which, I mean, not the direction, but the angle at which that wind is arriving at that particular coastline. Now, if that particular area has got shallow and calm waters, then it will mean that this longshore drift that was taking place here will still continue to happen and will continue to deposit material or sediment or sand out into the open water. And as that happens, obviously, you will have new land being created out into the open water. And it's that deposition of material that leads to the formation of a landform referred to as a spit. Now, of course, there is also likely to be a change in wind direction, like we said, and especially when there is a coastline change as well. So if the winds then are going to be blowing from this direction here, it's likely then to cause this spit here to begin to curve. As you can see, the spit is now becoming a little more curved because the wind direction has changed. So it's curved there and it's curved there as well. And as you can see here, it's starting to curve slightly again. Now, these ends where the spit has curved are referred to as hooks. So how many landforms so far? 2 landforms. So we have the spit and then we have the hook, or the recurved end. Sometimes it's called a recurved end. And then we also will have a salt marsh forming behind that spit, because of course this area behind the spit is going to be sheltered by the accumulation of the sand or the spit itself. So it's going to be a very low energy environment. So any material that is deposited there is not likely to be washed away by the waves because the waters are really, really calm there. So that will then lead to the development of a salt marsh. And those salt marsh environments tend to be very good environments for rare species of birds and also other rare species of rare plant species, and of course those plant species are likely to be halophytics or halophytes. So halophytes meaning that they can survive salty water. Okay. Now, there are a number of other depositional landforms that we need to know about. And those here, obviously, as shown, are bars, lagoons, tombolos, and sand dunes. Now, let's start off with bars. Now, a bar is going to be formed across a bay. Now, we've talked about the longshore drift process and how that moves sand along the coastline or sediment. Now, if there is a bay, then you may end up having the sand being moved by longshore drift across that bay. And when that happens, this particular part here where that blocks off that particular bay is referred to as the bar. Now again, of course, because the area behind that bar is going to be a low energy environment, since no waves are now going to be able to reach there, then it's going to be secluded, and therefore any deposition that has taken place there is going to remain fairly stagnant and stable, and that can create a lagoon where obviously you have a kind of a salt marsh environment forming. Then we have a tombolo. Now a tombolo is where you have longshore drift connecting the mainland to an island that is offshore. So as you can see, these two here have been connected, and that connection is what we are referring to as the tombolo. Then we also have sand dunes, and sand dunes occur when winds blow sand inland. So as the sand is blown inland, it begins to accumulate, and as it accumulates, you're then likely to have vegetation starting to grow on that sand. And as that continues to happen, the sand will stabilize even more and will be colonized by even more plants. And then, of course, the sand will also still be continue being blown further inland, and that will create a much wider area of sand dune environment, and those eventually will also be colonized by plants. But that's something that would be studied at a later level, so we'll just leave it at that. So sand dunes are formed when winds blow sand inland. So what kind of questions then are you likely to be asked regarding these depositional landforms? So you have identify the coastal landform or feature shown. So you may be shown one of these and asked to identify what it is. And then describe how a bar, tombolo, or sand dunes are formed. So of course, you may use a diagram. So of course you'd explain the process through which either one of these is formed. So at the start of the video, we talked about the fact that there are four main things that have determined the UK landscape. And we talked about geology, we talked about tectonic processes, we talked about glaciation, and then we also mentioned human activity. Now, of course, human activity has shaped the landscape of the UK because it changes the way that landscape looks like. And that has been done through several ways. And the first one, obviously, is settlement. And we know that coastal areas tend to be quite attractive places to live in. And as those areas end up with more people moving there to live, you end up with a lot more urbanization in those areas taking place. And of course, we know that people who retire tend to like to retire to nice parts of the country. So retirement migration is also likely to move to the coast. And as a result of that, obviously, that is going to change the look of the landscape, because it will now no longer just be land or just the coast without any development, but you will have housing, and then of course you'll have infrastructure, so like roads, railway lines, schools, hospitals, and so on, to support that population that is moving into those areas. So the landscape will change. And then we also have the influence of farming. And of course, we know that there are farms on coastal landscapes, and those also are changing the way that coastal landscape looks like. Then we have the development of industrial and commercial infrastructure and land use, and that obviously again will change the way the landscape looks like. And then finally, and quite importantly, is coastal management. Now, if we put up groins, or we build seawalls, or we put down rock armor or riprap, then that again is going to change the coastal landscape and the way that landscape looks like. So these here are ways in which human activity has influenced the coastal landscape here in the UK. Now, what kind of questions are you likely to be asked in the exam then regarding this kind of information? So we have the first one here says to suggest one reason why only a small percentage of the Scottish coastline is being protected. Now, of course, we know that the population in Scotland is quite low. And as a result of that, there's likely to be very limited protection, because we have to do a cost-benefit analysis. And therefore, if the population is low, then it implies that coastal protection may not be needed, because there is not as much infrastructure there that is valuable to protect. And then the second question here is saying for a named UK coastal landscape, explain two ways in which human activity is causing change. So you can talk about either one of these and explain how it's causing change in the coastal landscape. Then 3, explain one reason why some coastlines are protected whilst others are not. So again, here we are talking about cost-benefit analysis. And then we could also talk about prevailing wind direction as well. We could talk about the types of waves that occur in that along that particular coastline. So if we have more destructive waves in the winter, and those coastlines have got infrastructure and settlement, then they will definitely need to be protected. But if we mostly have constructive waves, then those kinds of areas are not likely to need any protection. So it just depends on how you would like to answer the question. So you can pick from quite a variety of reasons why coastlines here in the UK are protected or not protected. The next thing that we are going to look at is climate change and cliff processes on coastal landscapes. Now, of course, climate change will have or already does have, and will continue to have a very great influence on the coastal landscape here in the UK. Now, of course, if we are talking about climate change, we are talking about melting of ice caps and therefore leading to a rise in sea levels. And then we are also talking about an increase in temperatures, which will lead to thermal expansion, which means then that the volume of water in the seas will also increase. Now, of course, if we have a rise in sea level or thermal expansion, then it means that the intensity and the frequency of storms here in the UK will also increase. And of course, if we are talking storms here, we are talking about the fact that there will be more destructive waves coming into the UK. And of course, if there are more destructive waves, then the coastline is likely to be affected quite drastically, and a lot more erosion is likely to take place. Now, the types of erosion that are going to take place here are related to cliff processes, especially when talking about climate change. And the first one that we are going to look at is cliff erosion. Now, cliff erosion here is referring to a situation where you have the base of the cliff. So if I use the cursor here just to show you, the base of the cliff here being attacked by the waves. And as you can see here, this is actually a destructive wave because it's got a very, it's quite high. The wave height is quite high. Now, as this destructive wave hits this particular cliff, then it's going to start eroding it. Now, if there is a crack on the cliff or in the cliff, then that will mean that this wave here is going to keep on crashing into that particular crack and pushing water and causing a lot of pressure. And then as the wave retreats, it's going to blast out of that crevice or crack in the cliff face, and of course that's going to disintegrate the cliff slowly by slowly. So what's going to be formed as a result of that is a wave cut notch. So it's this area here that has been formed by that hydraulic action and abrasion that is being caused by this destructive wave here. Now, as that continues to happen, obviously, this wave cut notch is going to become bigger and bigger, or deeper and deeper if you like. And then, of course, it's going to leave an overhang above it because the cliff will have been eroded at the bottom here. So you'll have the wave cut notch, but above that, there will still be some part of the cliff that will be remaining, but it will have been undercut and will have no support from the bottom, and therefore eventually it's also going to fall under the pull of gravity. So as a result of that, you can see this orange arrow here showing that the cliff is actually in retreat. So it's going to keep on moving back as this process here continues to repeat. Now, this obviously is then going to leave a platform right here. So at the bottom here, we have a platform that has been left. And that is because this cliff was originally all the way here. But due to this cliff erosion, it has kept on retreating until it has got here. So this bottom part of the rock will still be left intact because it's below the surface of the water, or just at the water level surface, at the water surface level most of the time, and therefore is not really as affected by the destructive wave. So it will remain there, and this is what is referred to as a wave cut platform. So you may actually be asked to talk about how cliff erosion takes place, or how a wave-cut platform is formed. So that's one of the cliff processes that we need to know about. Now, the other cliff process is cliff slumping and rotational slips. Now, this happens where we have a variety of geology in an area. And in most cases, you will have a permeable rock above an impermeable rock. So at the bottom, you're likely to have impermeable rock, so it doesn't allow water to filter through it or to infiltrate it. And then at the top, you have geology that allows infiltration to take place. So what happens then is there's going to be intense rainfall, obviously, with climate changing. And of course, we have those storms, so they bring the rainfall. So those heavy rainfalls, that heavy rain is then going to cause the water to sink into the permeable layer quite quickly. And then when it reaches the impermeable layer below it, it's obviously going to stop infiltrating as quickly as it was and will therefore accumulate above that impermeable layer. Now, as that happens, obviously, it's going to compromise that top layer that is permeable, because it's going to become very heavy and saturated. And as a result of that, you're likely to have that cliff face start slipping, especially that top part that has that permeable layer. It's likely to start slipping off that particular cliff. And that is what we are referring to as rotational slips, and also slumping. So what kind of questions have there been in past exam papers with regards to this kind of information? So number one is to state one piece of evidence that mass movement is taking place on this cliff. So here the students were given a picture and they were then to look for evidence to show that mass movement, which is this cliff slumping and rotational slips, is taking place on that particular coastline. So if there is evidence, for example, of material that has eroded and then has been deposited at the bottom of the cliff, then that would be a piece of evidence. And then here, for this particular diagram here, you can actually see that this landscape here appears to be in kind of terraces. So this staggering or these terraces here are actually a piece of evidence to show that mass movement is taking place on this particular coastline. So explain one impact of climate change on coastal landscapes. So you can talk about what we have discussed here. We have, of course, rising sea levels, which will lead to more destructive waves and therefore a lot more erosion and so on. And then explain one reason why there may be an increase in the frequency of storms in the future. So again, you're relating that to climate change. Explain why there is an increasing risk of coastal flooding on many UK coastlines. Now again, with climate change, we are likely to have an increased frequency and intensity of storms at the coast, which then is likely to lead to coastal flooding. Describe how mass movement happens. You may use a diagram. So again, here we'll just draw a diagram to show how rotational slip or slumping takes place. And then finally, describe the formation of a wave-cut platform. You may use a diagram to help your answer. Now again, here would be describing what is happening over here where cliff erosion is taking place and causing the formation of the wave-cut platform that we talked about earlier. The next thing that we need to talk about is coastal management. Now, we are going to start off with the traditional approach to coastal management. And we also do know that coastlines, before a coastline is protected, a cost-benefit analysis is going to be done. So to determine whether it's worth protecting or not. And obviously, in a lot of cases, if we have a coastline that has a lot of infrastructure, then it's worth protecting because the cost of losing it would be a lot higher than the cost of protecting it. So how do we then protect it? We can use hard engineering or soft engineering. Now, the types of hard engineering that we have here are three, and the first one is a seawall. Now, of course, the seawall is a physical barrier that prevents or stops the waves from crashing onto the coastline head-on, and therefore will reduce on the erosion, because the seawall is going to absorb or reflect those waves back into the ocean. Now, as you can see, this particular seawall here is recurved, so meaning that it curves at the top, and that of course is going to deflect the waves back into the ocean, and in doing so it's going to protect this particular coastline. Now, the other thing that is very important to note is the advantages and disadvantages of each of these hard engineering methods. Now, they are also referred to as the costs and benefits, and the costs here implies the disadvantage, and then the benefit obviously being the advantage. And of course, if you are to be asked in an examination about the seawall, then you would say that an advantage of the seawall is that it's very effective at protecting the coastline. And then if you were to talk about a disadvantage, then you would say that it's very expensive. And then a second disadvantage would be that it spoils the look of the coastline. So it does not blend in with the natural environment. And then the second type of hard engineering used is groins. Now you can see them here. Now they are mostly, or in most cases rather, wooden groins. And as you can see, they are sticking out into the coast or into the sea. Now they have been put here to trap the sand, so to stop longshore drift from carrying the sand away from this particular coastline, and especially if it's a valuable piece of coastline or part of the coastline where you have infrastructure that is in place. So the groins stop longshore drift from taking place. Now, again, obviously, the buildup of a beach in such an area will act as a basic form of protection, because that sand or that beach is going to absorb some of the power of the waves and therefore protect the coastline. So, what then is a benefit of having groins? So they are, effective in protecting a coastline. So they increase the protection, and then limitations. Of course, they spoil the natural look of the coastline. And then the other thing that is very important for us to note is that they cause the terminal groin syndrome. Now, what does that mean? So if the sand is trapped on just one particular section of coastline, then it means that that sand is not going to reach other parts that are further along that particular coastline. Now, what that means is that those places that are further along the coast are going to be starved of sediment or material that would otherwise protect them. So that means that those areas are likely to have higher rates of erosion as a result of a different part of the coastline being protected. Then if we move on then to rock armor, or what is also referred to as riprap. Now, obviously, these are large boulders that are brought into the area or onto the coast and dumped along the coastline so that they can absorb the power of the waves or dissipate the power of the waves, if you like, or the wave energy. Now, of course, these ones, if we are talking about their benefits, they are quite effective, and they are also a little more natural than the first two. But the disadvantage, the cost or the disadvantage is that they are quite expensive, because they may have to be brought in from a different area, sometimes even be imported from a different country. So that makes them quite costly. Okay, so what kind of exam questions are being asked about hard engineering methods? So we have the first one here: identify one type of hard engineering used to protect this coastline. So you may have a picture which you can choose from, which you would use to identify what particular type of hard engineering is being shown. Then number two, explain one way in which hard engineering can reduce coastal erosion. What you need to do is just pick one of these and talk about how it reduces coastal erosion. suggests one reason why only a small percentage of the Scottish coastline is being protected. Now, we discussed this question previously in one of the previous slides, but you could use hard engineering to answer that particular question. The next question is to explain how hard engineering has been used to protect the coastline. So again, and the coastal landscape and community. So again, you'd pick one of these forms of hard engineering and explain how it protects the coastline. Okay, we will now move on to soft engineering strategies. So for coastal management. And soft engineering obviously involves the use of natural processes to protect coastlines. Now we have three here that we are going to talk about, and the first one is cliff stabilization. Now, of course, you're trying to ensure that the cliff does not experience slumping or rotational slips. Now, you would then obviously need to drain the excess water from those cliffs. And if we look at this picture that we have here, we can see that pipes have been installed on the cliff or in the cliff, and of course those pipes are going to drain off the excess water, and in so doing obviously they are going to ensure that the cliff does not become saturated and therefore end up slumping or slipping. Then we have planting of vegetation. Now again, on the same cliff face here, we do have vegetation. Now that vegetation will tend to stabilize the cliff face and the cliff, because the vegetation obviously will have roots, and those roots will go into the soil and therefore hold the soil together. And then we have beach replenishment. And beach replenishment, which is also referred to as beach nourishment, is where you artificially add sand onto the beach. And of course, by doing that, you then end up with a much wider sandy beach that then will protect that particular coastline. Now, of course, we can talk about some costs and benefits of these methods of soft engineering. So if we are talking about beach replenishment, for example, we can say that one of the benefits is that it's natural and fits in with the landscape. But then a cost would be that it's quite expensive to do, and also will need to be done regularly, because obviously with time the sand will be washed away, and therefore you will need to ensure that the sand amounts are maintained, and so you'll keep on having to do that beach nourishment or that beach replenishment. Then if we are talking about cliff stabilization, if we are talking again about the benefit, then it's going to leave that particular coastline in its natural state, so to speak, because no physical structure is being constructed here. It's just the pipes that have been put in, and these are quite inconspicuous, and they're just going to drain water off. So it still leaves the area it still leaves the area looking quite natural. And then in terms of benefits, is that of course it's going to reduce on rotational slips and slumping, and therefore protect this particular coastline. So what kind of questions are likely to be asked based on the information that we have just discussed on soft engineering? Now, the questions that we have here are actually fairly similar to the ones for hard engineering, only that we are now going to be doing them for soft engineering. So do have a look at them and see and consider how you would answer them if you were to find them in the examination. Now, those two types of management that we've talked about, so hard engineering and soft engineering, are what was predominantly used in the past here in the UK. However, due to the expense or the cost of protecting or managing coastlines, the approach has actually changed. So the government and local authorities have changed the way in which they manage the UK coastlines. So they have sought to adopt a more holistic approach. Now, we did mention earlier the terminal groin syndrome, which was where using grains to protect one part of the coastline would have a severe impact on areas further along that particular coastline that have not been protected. So instead of just protecting sections of coastline along the UK, then the new approach is, or the modern approach is, a lot more holistic. So it looks at the coastline at the coast in its entirety and not just sections which are isolated and do not affect each other. Now, this obviously means that the entire coastline is taken into consideration and not just an isolated section of it. This approach is referred to as the Integrated Coastal Zone Management, or ICZM. Plans called shoreline management plans are drawn up for long stretches of the coastline. Now, there are 4 choices that UK councils can make when using these shoreline management plans. And the first one is to hold the line. Now, hold the line here basically refers to the use of sea defenses, so the ones that we mentioned earlier, so hard engineering to maintain the coastline at its current position, so to ensure that it does not retreat, so to maintain it where it is. So that involves the use of hard engineering, which obviously it is quite costly, and a cost-benefit analysis will need to be done to identify which areas will need that hold the line strategy. Then we also have advance the line. Now, this is the use of sea defenses again to advance the coastline out into the sea, and this can be very expensive. And then we have the third strategy here, which is referred to as strategic retreat. And this involves allowing the coast to retreat slowly and gradually as people are relocated from areas that are at risk from coastal erosion. Now, this, of course, will be areas, or these rather, will be areas that have been identified as not being very high value areas and therefore can be allowed to erode slowly. And of course, you're going to move any people that are going to be living in those areas gradually as the coast is allowed to come further inland. Then lastly, we have the do nothing approach, and this of course is likely to be in areas that do not have that much of an economic value especially, and therefore can be allowed just to continue eroding. So that is basically letting nature take its course. Now interestingly, in the last exam, the 2025 paper 2 exam, there was an image like this one. This image was in the paper, and the students were asked to identify what kind of coastal management strategy is being used on in this particular coastline. And as you can see here, this is the do nothing approach, because nothing is really being done to protect this particular coastline. And this is not rock armor. These are rocks that have been eroded from the coastline itself or from the cliff and so on, and therefore is not necessarily rock armor that has been put down. So this is a do nothing approach here, which then answers this first question that we have here. And then the second question that could be asked here is to explain one of these choices of coastal management. So to describe, or to explain rather, one of these 4 that we've talked about, and then explain why the modern approach to coastal management is better than the traditional approach. So for this particular question, you'd obviously be saying that the modern approach is a lot more holistic, so does not just consider sections of coastlines, but looks or considers the coastline in its entirety. So it does not protect some parts of the coastline at the expense of others. So you would be making that argument or giving that explanation as to why the modern approach is better than the traditional approach. Okay, so let's move on to the third part of section A, and that is river processes and pressures. Now, of course, this section is about rivers, and when we are talking about rivers, we know that they have a long journey all the way from their source to their mouth. So we also do know that the river will flow through 3 main sections. And the first section here obviously is the upper course, and we can see that the land around here is quite steep. And then we have the middle course, which is not as steep, and then we have the lower course, which is a lot flatter, so is even more gentle sloping, if you like, tending towards being completely flat. And so the river will change along its course, and the changes that it's going to make are mostly done through erosion, transportation, and deposition. And those three processes of the river lead to the formation of certain landforms. And in this particular section, we will look at some of those landforms that are created by erosion, transportation, and deposition. So those three jobs that a river does, we did talk about erosion in the coast section. The processes of erosion for rivers are similar to the ones that we talked about for coasts. So that is hydraulic action, abrasion, attrition, and solution. So we are not going to go back, we are not going to talk about those again. Instead, we'll go on to the types of transportation. So material is being transported by the river, or sediment is being transported by the river. And one of the ways that that sediment is transported is through traction. And traction is where the big boulders are rolled along the riverbed. And then we have saltation, and saltation I like to look at as a leapfrog motion, and a leapfrog motion because smaller particles, so pebbles in this instance, are bouncing off the bottom of the riverbed and moving forward, being pushed by the river water, and then they bounce off again and keep on moving forward. Now, that kind of leapfrog motion is what is referred to as saltation. So it's a type of transportation, or a way in which rivers will transport sediment. And then the third one is suspension. Now we know that some of the particles or sediment, some of the sediment in the water is light enough to be carried along in the flow of the water. And that sediment is going to be carried in suspension. In other words, it's going to be suspended in the water and therefore move along with the flow of the water. And it is this suspended material that normally discolors the water in times of heavy rain. It's actually what makes the water look very brown in color. Then finally we have solution, and this is where we talked about weak acids in the water, in the rainwater, dissolving some of the rocks, or the rocks that are in the water, by breaking down their chemical or mineral composition, and then those rocks getting dissolved and therefore being carried in a solution state. Okay, so let's look at a couple of exam style questions that would be asked on this particular information here. So identify which one of the following best describes the gradient of the river. So here you're either talking about very steep, or gently sloping, or almost flat, whether it's upland landscape as well, or lowland landscape. Explain one way in which rivers transport their load. Now, of course, here we would be talking about one of these types of transportation that we have just mentioned. So you mention the type of transportation and then explain how it happens. Then question 3, for a named UK river that you have studied, explain one difference between its upper course and its lower course. Now here you can talk about several things. You can talk about the gradient of the river. You can talk about the landforms that are created at those various stages. So the upper course, the middle course, and the lower course of a river. You can talk about the velocity of the river and things like that. We'll get to a lot more detail regarding different characteristics and different river landforms and different different channel characteristics that we can then use to answer this question. And then the next one, explain two differences between the upper course and lower course of river landscapes. Now again, this is a similar question to question 3, only that this one is 4 marks, and you are required to explain two differences. Then lastly, explain two ways in which rivers can erode the landscape. So again, we are talking about the types of erosion. So we are talking about hydraulic action, abrasion, attrition, or solution. So we pick 2 out of these 4 and then explain how they take place. The next thing that the specification requires us to know is the landforms that are created in each course of the river. So we are going to start with the upper course of the river, and we are going to look at what landforms are created there. And here we have V-shaped valleys and interlocking spurs. Now, when we are talking about V-shaped valleys, we are talking about valleys that look like the one that we have here in this picture. So it's a V in shape, and the reason it's got a V shape is because the river is cutting downwards in the upper course. So at this point, the river doesn't have as much water, so the erosion is taking place downwards. So vertically, other than laterally, so other than sideways, and because of that, it creates a steep profile on the sides of it, because it's cutting downwards, and you end up with this V shape here. So that's a V-shaped valley, and it's one of the landforms that are created in the upper course of a river. And then we have what are called interlocking spurs. Now, because again, like we said, the river here is not flowing that fast because there is not as much volume of water in the river, then the river will try to find the path of least resistance, and that is likely to be areas that have geology that is not as resistant to erosion. So the path of least resistance will mean that the river is flowing through areas that have geology that is softer. So as that happens, then the river will weave and curve as it tries to find that path of least resistance, and therefore you will have ridges sticking out into the river, like this ridge here. So this river must be curving around here and then coming back this way and then again this way and so on. So you end up with all these ridges that are going into that V-shaped valley, such that you cannot see the entire V shape all the way across the landscape. And these ridges that are forming part of this V-shaped valley here are what we call interlocking spurs, and that obviously is the second landform that is created by rivers in the upper course. Then the other one that is very important for us to remember, and which we are likely to be asked to draw a diagram of and to explain its formation, is a waterfall. Now, of course, a waterfall will form where we have two different bands of rock. So at the top here, you can see this is a different type of rock to the one that is at the bottom. And in the formation of a waterfall, the top rock is the harder, more resistant rock. And then the lower rock is a lot less resistant. So what happens is that as the water flows over the harder rock, it's then going to drop towards a softer rock. And as that happens, obviously, it's going to strike the softer rock, and with time, that softer rock here is going to keep on eroding. And as you can see here in the second diagram, this has carved out a lot more. This softer rock has carved out a lot more as it erodes further. Now, we do know that the type of erosion here is likely to be hydraulic action and abrasion and so on. Well, those two, so hydraulic action and abrasion. And then what forms as a result is what is referred to as a plunge pool, because the water obviously is sort of plunging downwards and then cutting into the landscape. So it's referred to as a plunge pool. Now, because this softer rock keeps on eroding and retreating or moving back, then that leaves or that causes the upper rock to be undercut. So in other words, the more resistant rock will have nothing to hold its weight around this area here where the softer rock has retreated. So it has now been undercut, and due to the pull of gravity, that rock will eventually break and disintegrate, obviously, and fall to the bottom of this plunge pool. Now, when that happens, these rocks will be twirled around the plunge pool, making it a lot wider and a lot deeper. And then eventually, obviously, these rocks will be washed away as they get smaller and smaller, because there is attrition taking place initially as they hit against each other and break up into smaller particles. And then also, the scraping, so the abrasion is also causing them to wear away, and then eventually obviously they're going to be washed away. So we then end up with a process, or the same process, repeating itself over time. And as that happens, the waterfall will keep retreating. And this part here that has retreated is what is normally referred to as a gorge. So the space that has been left behind as that waterfall retreated. Now, what kind of questions then are we likely to be asked with regards to this information here on the landforms in the upper course of a river? And one of them is to identify which of the following best describes the gradient of a river. We talked about that in the previous slide, so we are going to skip that one. For a named river that you have studied, explain one difference between its upper course and lower course. So of course here you'd be talking now the landforms in the upper course. So you talk about what kind of landforms you get here and why. And then explain how V-shaped valleys or interlocking spurs form. So here you describe what we have just talked about regarding the V-shaped valley and vertical erosion, and then the geology in the area and interlocking spurs. And then explain the difference, the two differences between the upper course, or explain rather two differences between the upper course and lower course of the river landscapes. Now again, that is similar to the second question here, so we just need to add one additional difference to the first one. And then number 5, explain how both processes of erosion and geology create river waterfalls. So here you would basically, and you may use a diagram to help your answer. So here you'd basically be drawing a diagram showing these 4 stages in the formation of a waterfall and talking about them, and especially with regards to the erosional processes that are taking place and the geology, so the types of rock and their resistance and how that leads to the formation of a waterfall. The next part of the specification that is important for us to talk about is weathering and mass movement in the upper course of a river. Now, in the upper course, there are 3 types of weathering taking place. So all types of weathering are taking place here. So freeze-thaw weathering. And of course here, we are talking about the fact that these are mountainous areas, and therefore they are likely to have a big difference between daytime and nighttime temperatures, especially in the winter. So that temperature disparity is likely to allow water to go into rocks during the day, so cracks in the rock. And then at night, the water is going to freeze because the temperatures are likely to drop below freezing at night. And we did mention earlier that ice takes up 10% more volume than water, and because of that the ice is going to keep on pushing the cracks in the rock outwards, and eventually that rock is going to break. And that's why in a lot of upland landscapes here in the UK we have what is referred to as scree. Now scree refers to rock fragments that have been broken up and left on the landscape as a result of freeze-thaw weathering taking place. Then the second type of weathering that is taking place here is biological weathering, and this is by plant roots. As plants go into those cracks in the rock, obviously, and then the plants begin to grow bigger, the cracks will continue to expand, and eventually the rock is going to break up. And then we also have chemical weathering, which is where weak acids in the rainwater dissolve the rock. Then the next thing that we need to talk about is mass movement. Now, of course, this is the movement of material or sediment in these particular areas. Now, having talked about scree or rock fragments on the landscape, it's then important for us to talk about what type of mass movement is going to take place, and these are landslides and sometimes mud flows. But mud flows are they are quite rare here in the UK. It's mostly landslides as rocks and other material come down the slope, and this is especially when there is heavy rain. And that heavy rain obviously is likely to destabilize the material that is on these steep slopes and cause it to come running down. Now we then have the next type of mass movement, and that is soil creep. So in areas where the soil has been loosened by rainwater, and the profile of the land, or the geology or topography of the land is quite steep, then you may have soil and mud flowing down those slopes. So that is soil creep. Now, what type of exam questions are we likely to get based on this information here? So describe the role of weathering in the upper course of a river. So here you'd be talking about one of these types of weathering and how it's impacting on the river in its upper course, or the landscape in the upper course of a river. So we've talked about freeze-thaw weathering, and we'll be able then to explain that. And then explain two types of mass movement that occur in the upper course of river landscape. So again, we'll pick one of the types of mass movement we've discussed and then explain how it happens. The next thing that is very important for us to talk about is the Bradshaw model. Now, the Bradshaw model shows us how the river's characteristics change as it flows from the upstream to the downstream. Now, looking at this diagram here, we can see that the first 5 characteristics increase as the river travels downstream, while the last 3 decrease as the river flows downstream. Now, we are going to talk about a couple of them and then move on to the next slide. So the first one here is the discharge of the river. Now, the discharge here refers to the amount of water or the volume of water that is passing through a particular point in the river at a given time. Now, that is measured in cubic, so in cubic meters per second. Now, we can see that in the upstream, the discharge will be very low. Now, we did say earlier that in the upper course, the amount of water in the river is very low. And as you can see here, that is actually the case in the upstream. But as we progress and move downstream, the amount of water in the river is increasing. So the volume of water or the discharge of the river is increasing. Now, because of that increased discharge, then there will be a lot more erosion, because the water will have there'll be a lot more water, and therefore there will be a lot more erosive power or energy, which then means that the occupied channel width, so the width of the river, is going to increase as well as erosion takes place, and especially as a result of hydraulic action, the shear force of the water just causing erosion to take place, and of course the other types of erosion as well, so abrasion, attrition, and so on. And then the channel depth as well, so the river will be cutting outwards and downwards as well, but as we go closer to the downstream, or further down, a lot further downstream, then there will be more of lateral erosion, so sideways other than downwards. However, both the width and the depth of the river are going to increase. And of course, we have the average velocity, which is the speed of the water, and that will increase as well, because as we get more water from tributaries, and the volume of the water continues to increase as we move downstream, then that river is likely to flow a lot faster. And then the other thing that causes a river to flow a little faster, it's worth mentioning here, is that because of the erosion that is taking place and the river channel being a lot smoother, because it has been shaped by abrasion and hydraulic action, then the water is able to flow with a lot less resistance. So there will be a lot less frictional force that is slowing down the water, and therefore the water will speed up. So the velocity will be higher for that reason as well. Then the load quantity here refers to the amount of sediment that the river is carrying. So load, because it's being carried by the river, and then the quantity is the amount of it being carried. And we know that because a lot of erosion is taking place as the river flows downstream, then that means that the load quantity will also increase as the river flows downstream, because a lot more sediment is being collected along the way. Then if we talk about the last 3 here that decrease, so that is the load particle size. That's the first one. So that is the size of the sediment being carried. And we know that in the upper course, the material has not yet been eroded and has not become smaller just yet. And as a result of that, the load particle size is likely to be a lot bigger. And then it's also likely to be a lot more rough, or a lot more, have a lot more edges, and therefore not necessarily smooth. But of course, with erosion, process of erosion such as attrition and abrasion, the sides of it, well, it's going to get smaller first of all to pebbles and eventually sediment, but it's going to be a lot smoother and a lot rounder due to those processes of erosion. So the load particle size will decrease. The channel bed roughness will also decrease. So instead of the channel bed being very, very rough, it's going to become a lot smoother because it will have been eroded by the river as it flows through, and as the river gets a lot more water. And then the slope gradient, obviously, or the slope angle as well, is going to decrease as we go downstream. We did say, and you did mention, that in the upstream the river is a lot steeper, and then it will become a lot, the gradient reduces as we go towards the downstream. Now, what kind of questions then can we be asked with regards to the Bradshaw model? So identify which one of the following best describes the change in the discharge of UK rivers from source to mouth. So you then here, this question was asking about obviously the discharge, and of course the right one to pick here would have been that the discharge is going to increase as the river moves downstream. And that could be for any of these here, the first five, and then for decrease, any of the three at the bottom. Then for a named river in the UK, explain why sediment load and average and velocity change along its course. So you have your named river, which you're going to write down, could be River Tees, and so on. And then say what will happen to the sediment load as it travels downstream. So of course that sediment load is going to increase, so you explain why. The velocity is also going to increase, so you explain why. Okay, so let's move on then to the landforms that a river will create in its middle and lower course. Now, the first one that we are going to talk about here are meanders, or the first ones we'll talk about are meanders and oxbow lakes. Now, a meander obviously is a bend in a river, and the river will bend in the middle and the lower course. And at this point, the river is flowing in a deeper and wider U-shaped valley, as erosion becomes lateral other than vertical. So we did mention that lateral erosion is where the river is eroding outwards other than cutting downwards. Now, the water in the river does not flow in a straight line. Instead, it flows in a corkscrew pattern called helicoidal flow. So helicoidal flow here meaning that it's spinning as it flows. And as a result of that, the river's energy will be sent sideways, leading to that lateral erosion that we are talking about, because it's helicoidal flow. So it's moving in a kind of a circular motion, so eroding outwards. Now, as this happens, the outer part of the meanders have the fastest current. Now, of course, these here are the outer parts of the meander, and it's because of that helicoidal flow that these outer parts of the meander are going to be eroded a lot faster, as you can see in this diagram here. Now, as that happens, then you will end up with a very steep edge forming on those outer parts of the meander, and those are referred to as river cliffs. So those are also landforms that are being created in the middle and the lower course of the river. Now, on the inner part, however, there is a lot. The flow of the water is a lot slower. So instead of the erosion that is taking place in the outer part, on the inner part you will have deposition, because the river's energy is a lot less, and therefore some of the material that is being carried along is being deposited other than going along in the flow of the water, because the energy of the water is a lot lower. So As that happens, if we look here at the neck of this meander, the erosion is taking place on the outside, and eventually, and then also the deposition is taking place on the inside. So the deposition here, for example, will continue, but then the erosion here as well is going to continue. And eventually, as that continues to happen, the neck of this meander is going to be completely compromised, and the neck is going to eventually join, such that the river now is going to flow in a straighter, more efficient and faster channel. And then because of the deposition that was taking place on the inner part of the meander, you will have that meander being cut off. And when the meander is cut off, it then forms an oxbow lake. So here we have talked about a couple of landforms. We've talked about the meander, which is the bend in the river. Then we've talked about the river cliff as well, and then we've talked about oxbow lakes. So those are landforms that are created in the middle and in the lower course of a river. But then we also have other landforms, and those will include levees. Levees are embankments that will be formed on the either side of a river, and they will happen, or they will be formed when the river bursts its banks. Now we know that because the volume of water is quite high in the lower course, that when you get an intense amount of rainfall in the drainage basin, then the river, the water is going to flow from the upper course and into the middle course and lower course fairly quickly. And of course, the middle and lower course is also receiving water from the drainage basin itself. So because it's receiving so much water, then flooding is likely to take place. So the river during times of storms is going to be carrying a lot more sediment, and therefore as it bursts its banks, it's going to deposit some of that sediment on either side of the river, and that is going to build up those embankments, and those embankments are what we are referring to as levees. And then we also have the floodplain, and this is the area around the river that is flooded when the river floods its banks. And of course, it's going to be a very wide area because the water will flow over a fairly long distances sometimes, and that obviously leads to the deposition of the material that the river is carrying. And one of the reasons why there's a lot of settlement on floodplains is because those the sediment that is deposited normally contains a lot of rich minerals that then make the soil quite fertile. So a lot of settlement took place in these floodplains due to people doing agriculture or farming in it. So floodplains. And then we also have deltas and estuaries. Now deltas are areas of deposition at the mouth of a river. So, of course, as the river joins or enters the sea, the water is going to be slowed down because it's coming across another body of water, and therefore the river that was flowing obviously is going to be slowed down by the other body of water that is going to meet the sea, and therefore will slow down, and some of the material that it's carrying is going to be deposited in that river delta, so at the mouth of a river. And of course, sometimes the main channel of the river is likely to get blocked, and when it gets blocked, the river will have many little branches that will develop as it tries to find a way to drain the water out into the sea. And those small little channels of river that are created at a river delta are referred to as distributaries. So not tributaries like the ones that join a river, but distributaries because they are distributing the water into the sea. Then if we are talking about estuaries, estuaries are similar, to some extent are similar to deltas, but estuaries will ordinarily get the tide coming up them from the sea and washing up, and then sometimes washing out, and is likely to be marshy and swampy, and sometimes is likely to be in most cases is likely to be a habitat for rare species of plants, animals and birds. Okay, so what kind of questions are we likely to get with regards to this information? So the first one is to identify which one of the following is the best description of the landforms shown. So that one was showing a particular landform in the middle or lower course of a river and was asking the students to identify which one it was. So either Oxbow Lake, a meander, or river cliff, if you like. And then the second question, explain how both the processes of erosion and deposition create river meanders. You may use a diagram to help your answer. So again here, you are talking about the formation of an Oxbow Lake or a river meander. Actually, this one is a river meander in this particular case. So you're talking about how that meander is getting eroded. Now, you could also be asked to talk about, to create Oxbow Lakes. So you then go right to the end where you're explaining how the meander is getting eroded, eventually to form that Oxbow Lake. The next thing we need to talk about is flood hydrographs and what factors affect them. Now, a flood hydrograph will show us how a river will change due to rainfall. So during a storm event or a rain event. And it has bars, and those bars will show us the rainfall from the point when that rainfall began. So we can see here we have the time of day. So this here is 12 o'clock, and then we go all the way up to midnight and then to 12 o'clock and so on. So that's day 1 and that's day 2. And these are the bars here. So we can tell when we had the peak rainfall, which is shown by B here. So that is the peak rainfall when we had the most rainfall, and would be able to tell what time that occurred. Now, we then will have a line as well, which shows us the discharge of the river. Now, the discharge here, we did mention earlier that the discharge refers to the amount of volume of water that is passing through a particular point in the river at a given time. So that shows us the amount of volume of water. And of course, as the rain event starts, initially the amount of volume of water in the channel is quite low, but then as we carry on, and after, especially after the peak rainfall, we then see a very steep rise in the quantity or volume of water in the river until it gets to its peak, and then which is referred to as a peak discharge, and then it begins to fall as the river drains that water away towards the sea. Now, a couple of things here that are worth mentioning is the rising limb. So that is the water arriving in the river. And then the falling limb, which is the water leaving the river. And then the other thing that is important to mention is the difference between the peak rainfall, which is B here, and the peak discharge, which is here. Now, that difference between the time difference rather, between the peak discharge and the peak rainfall is referred to as the lag time. Now, the shorter the lag time, the more likely that river is going to flood. And the longer the lag time, the less likely the river is going to flood. Now, there are certain factors that will affect the flood hydrograph. And we are going to discuss them because they are likely to be asked about in the exam. The examiners really like asking about them. And the first one we are going to talk about is urbanization. Now, urbanization or settlement, if you like, is referring to areas that have got a lot of buildings or infrastructure in them. Now, we know that such areas will have a lot of tarmac and a lot of concrete, which then means that infiltration is going to be greatly reduced. So there will be a lot more surface runoff, which means that the time that it will take for that rainfall to get to the river is going to be a lot shorter. So the water will get there a lot faster. And because of that, it will mean that the lag time is going to be a lot shorter. And we did say that when we have a short lag time, then we are likely to have flooding taking place. And then the other one to talk about here is deforestation. Now, deforestation obviously being the cutting down of trees. Now, when we cut down those trees, we are likely to have a shorter lag time, and that's because trees normally intercept the raindrops. So interception, obviously, it's a kind of interruption to the raindrops as they attempt to get to the ground. And because they are being interrupted or intercepted, then it takes time for those raindrops to get to the ground and therefore start flowing towards the river. So that will slow down that lag time, or will increase that lag time and slow down the water from reaching the river, and therefore increase the flood risk. And of course, without trees, we do know that trees normally soak up some of the water, and therefore without the trees, there is no vegetation to soak up that water, and therefore the risk of flooding again is higher because there will be a lot more surface runoff and a shorter lag time, which will then lead to flooding taking place. Then we have what is referred to as antecedent rainfall. Now, antecedent rainfall is the rainfall that has fallen recently. So if you have had recent rainfall, it's likely to cause the ground to be quite saturated. And because the ground is saturated, it's not able to take any more water in when there is more rainfall taking place. And as a result of that, the water then will accumulate above the surface and then will become surface runoff, and that will cause the river to receive a lot of water within a short period of time, so a short lag time, and that will increase the flood risk. Then finally, we have afforestation. Now, afforestation is obviously the opposite of deforestation. So afforestation, you're planting trees, and when you plant trees, you will have more interception, you will have more absorption of water by those trees or that vegetation that you have planted, and therefore the lag time will be a lot longer, and the surface runoff will decrease, and that will reduce the flood risk in an area. Okay, so let's look at the questions that you're likely to be asked with regards to flood hydrographs. So state one reason why planting trees can reduce the risk of river flooding. So that obviously would be interception. And then explain one reason why high discharge is likely to increase erosion. So that one here, obviously, you're just talking about the river having a lot more energy to erode. I think this question here should not necessarily be particularly to do with flood hydrographs, but it's good that we mention, obviously, that high discharge means that the river has more energy and therefore more erosive power. And then explain two reasons why human activity can cause river flooding. Now, we've mentioned them. So one of them is urbanization, because as we build more housing and infrastructure, we are creating impermeable surfaces, meaning that we're increasing flood risk, especially on floodplains, when we build on floodplains. And then deforestation is the second one. When we cut down trees, we reduce interception and increase surface runoff, leading to a short lag time and therefore an increased flood risk. Now, you can also talk about, okay, yeah, so those are the two main ones. And then explain two ways in which human activities can affect storm hydrographs. So in this one, you can talk about urbanization, deforestation, and afforestation, and then explain how either one of the three affects the flood or storm hydrograph, whether it's going to reduce lag time or whether it's going to increase lag time. Then analyze, so this one here was an 8 marker, the last one. So analyze figure 3, which is a hydrograph showing the changes in discharge of the River Severn in cumecs, so in cubic meters per second, at Bewdley in its lower course over 1 year. So they had the flood hydrograph showing Bewdley, and then assess the view that physical processes are largely responsible for river flooding. You may use evidence from figure 3 and your answer. So because this is an 8-mark question with an infographic and it's for paper 2, we would need first of all to analyze that figure that we have been given. So talk about the physical processes that we can see there that would influence river flooding in this area in Bewdley. Of course, talking about the trends that we can see, the general trend, the main trend that we can see, talking about the highest and lowest, talking about any anomalies that we can see, and then trying to manipulate any data that we have been given in that particular hydrograph. And then on top of that, we would then need to talk about other processes other than the physical processes that we can see in the infographic. So processes such as urbanization, deforestation, or any afforestation that has taken place there, and then come up, weigh them all up and then come up with a definitive judgment or conclusion about whether it's physical processes that are largely responsible for river flooding or whether there are other factors that are more important. So other factors such as urbanization, deforestation, and so on. And of course, by doing that, I would have a balanced answer that has weighed all sides and all options and has come to a definitive judgment. The river case study that has been used in our specification is the Sheffield Floods of 2007. Now, there are a couple of things that we need to know about this case study, and we'll start with the physical causes of the floods. Now, when talking about the physical causes, one of the causes was antecedent rainfall. Now, on the 15th of June, there was 90 millimeters of rainfall that fell in Sheffield, and this is a month's worth of rainfall. And of course, this left the ground fairly saturated with water. And then 10 days after the 15th, so on the 25th, another 100 millimeters of rainfall fell. Now, because the ground was already saturated, there was now a lot of surface runoff, which led obviously to a short lag time with the water reaching the river very fast, and that is what led to the flooding in Sheffield. Then the next physical cause is the relief of Sheffield. So Sheffield is surrounded by 7 hills, and these are quite steep, obviously, and the water will flow down those hills quite quickly as it comes towards Sheffield. And Sheffield is located at the foot of the Pennines, so which then means that it's on flatter ground or lower ground that is at the foot of these hills. And of course, that water reaches there quite quickly. And then that is then made worse by the fact that it's at the confluence of 3 rivers. Now, that being the River Don, the River Rivelin, and the River Loxley. These rivers are bringing a lot of water into Sheffield, and then they merge into one in Sheffield, meaning that that water is likely to, overflow from the river due to the volume of it that is arriving at the same time and merging into one. Now, those are the physical causes. Now, what about the human causes? Now, of course, Sheffield is going to be heavily urbanized, so it's going to have a lot of concrete and tarmac that then causes a lot of surface runoff other than infiltration. Now, then we also have poor drainage. So the drains in Sheffield were not sufficient to cope with the amount of water that they got within that short period of time. And they were obviously inundated, and that led to more surface runoff. Then we have poor flood defenses. Now, the flood defenses that were in Sheffield at the time were not sufficient to protect the town from flooding, and therefore they were easily broken or overtopped, or the water went above the flood defenses and flooded Sheffield. Then as far as the impacts of the flood are concerned, we've got them here. If you'd like to stop the video and look at those, you can go ahead and do so. And then I've also done a video that covers the entirety, or that covers these Sheffield floods in a lot more detail. If you were to want to watch it, I'm going to link it in the description. Now, what kind of questions are you likely to get with regards to flooding, and that would be related to the Sheffield floods? So explain one way in which human activity can increase the risk of river flooding. So we can talk about any one of these human activities here, or human causes, and then analyze figures 4 and 4b. So this here is an 8-mark question, which are 2 maps of the UK showing its population density. So that would have an implication, obviously, on urbanization in an area. And then its altitude, so the height above sea level. So that would be in relation to the relief of places such as Sheffield, for example. and its altitude are above sea level, shown in figure 4b. Assess the relationship between altitude and population density in the UK. So you'd be talking about the height of the land and how that relates to the population density of the UK. Now in this question here, you would obviously analyze the figures that you have been given and then talk about the relation between the altitude, so the height of the land, and population density. And we know that population density will obviously be lower in areas that have high altitude because they are a lot harder to build on. They are a lot harder to farm on as well. But then the population density obviously would be a lot higher in low-lying areas or in lowlands. And that's because the altitude there is low, or the land is fairly flat, and therefore allows for building both settlement and infrastructure. So if that was then to be related to flooding, then you talk about the fact that that high population density in those lowland areas, which are likely to be floodplains, is likely to cause a lot more surface runoff, and then of course a reduced lag time and a higher flood risk. And then another question here that is an 8 markers, number 3 here. Analyze figure 2a and 2b, which have information about major flood events in England and Wales between 1920 and 2019. Assess the physical and human reasons for the changes in flood events in the past 100 years. You must use evidence from figure 2a and figure 2b. To help your answer, so to aid with your answer. So now here obviously you are to analyze the two figures that you have been given and then assess the physical and human reasons, and we can see some of those possible physical and human reasons here in the Sheffield flood case study. So these are the types of questions that would be related to a flood case study that we have done here in the UK. So lessons were learnt obviously after the Sheffield floods, and several measures were put into place. Now, of course, these were either improvements or new measures that were used in Sheffield to mitigate the flood risk in the area. So we are going to talk about some of the types of hard engineering that can be used. So whether some of these are just general and others are related to what happened in Sheffield. So hard engineering and soft engineering. And we know that when we are talking about hard engineering, we are talking about physical structures that are put in place to reduce the flood risk. And then if we are talking about soft engineering, we are talking about working with nature to reduce or to control the flood risk or to mitigate it. So the first type of hard engineering are flood walls. Now, obviously, these here are built alongside the river to increase the holding capacity of the river, so the amount of water that the river can hold, because the walls will be on either side and will be blocking that water from overflowing from the river and flooding the surrounding floodplain, or flooding the floodplain that is around it. Now, what are the benefits of flood walls? Now, it's obviously suitable for city centers. Now, cheap here is quite relative because it depends on what the length of flood wall is, or flood walls is, that you're going to put up in an area. If it's over an extended area, then it's likely to be expensive. If it's to protect a small area, then it's not going to be as expensive. But it's suitable for city centers. And the reason why it's suitable for city centers is because it's going obviously to protect them from water overflowing the that river channel and then causing damage within that city center. What are the limitations? Now, the limitations is that they move. One of the main limitations is that they move water very fast and may increase flood risk elsewhere. Now, what does that mean? Because the water that would have flooded that particular area has been retained within the river channel, then that means that the volume of water that is going to remain in the channel is going to be quite high. So as the river leaves those areas that will have protection, so the flood walls, it's likely to cause a lot more erosion, not erosion, but a lot more flooding in those areas that are further downstream. The second type of hard engineering is the use of levees. Now, levees are obviously raised embankments. Now, you can build artificial ones, or you can remove excess material from the river and then put it as embankments on either side of the river channel. Now, the levees, obviously, again, like the flood walls, are going to increase the river's holding capacity and therefore reduce the flood risk. Now, again, when we are talking about their limitations, we are saying that it's going to be expensive to put these levees up. And then also it can increase flood risk elsewhere, just like we saw with floodplains. And then these levees can also fail. If they fail, because they will have been holding some water behind them, then that water is likely to flow into those urban centers quite quickly and cause a lot of damage. Then the last one is diversion channels. And this here is to divert water from city centers, for example. So you can build channels to divert the water and obviously reducing the flood risk in those city centers. Then when it comes to soft engineering, we have floodplain restoration. So this is where vegetation and greenery are restored to allow for infiltration and for interception to take place. So the second soft engineering method here that we are going to talk about is river channel restoration. And when talking about river channel restoration, we are talking about meanders being rebuilt, for example. And we know that if meanders are rebuilt, it means that the water will have to go through a bend in the river, and therefore the velocity of the water is going to be slowed down, which then means that the risk of flooding is going to be lower as well. Then we also have banks being lowered to allow water to flood parks instead of city centers, for example. And then you could also do afforestation or afforestation where you're planting trees to, of course, to increase the infiltration in the area, the interception in the area, and the uptake of water through the roots of those trees or that vegetation, and that obviously will reduce on the amount of water that is going to be flowing into the river and therefore reduce the flood risk. And then the other thing that you could do is dredging, and dredging is where you remove the excess sediment from the riverbed, and by doing that, of course, you are increasing the holding capacity of the river and therefore reducing on the flood risk or mitigating that flood risk. Now, what kind of questions are you likely to be asked with regards to this kind of information? So identify one type of hard or soft engineering used to protect this area. So in this particular case, the students would have been given a picture with a type of hard or soft engineering, which they can then, they can then name, they can give the name of and get the mark for it. Then explain one way in which hard or soft engineering can reduce river flooding. So again, here you're mentioning one of these types of hard or soft engineering and then explaining how it will mitigate flood risk. Explain one benefit of using hard or soft engineering to reduce river flooding. So here you're talking about the advantages and disadvantages. No, you're talking about the advantages, but you could also be asked to talk about the disadvantages. Then lastly, explain how soft or hard engineering has been used to protect this community. So again, here you would have been given a picture with one of the hard or soft engineering strategies, and you would then need to name it and then explain how it would be, how it would protect that particular community from flood risk. That brings us to the end of this video on the UK's evolving physical landscape. This video only covers section A of paper 2. I have previously done revision videos for all 3 sections in paper 2. You can therefore watch the video for topic 6 and topic 5. They will be linked in the description. I will also be doing a follow-up to today's video for the most examined areas for section B of paper 2. Please ensure that you are subscribed if you would like to be notified when I post it. Thanks once again for joining in this journey towards excellent exam results. The very best wishes in your revision and exam, and see you again soon. Bye-bye.